structure of simplexes. Okay, so let's say we have a simplicial complex, or in short we can call it a complex K, and we define something called an n-chain group, which we denote as C of n. C means chains, n means this is an n-chain, as the additive group over the set of integers. So this is the definition of an n-chain group. And this is an additive group over Z, or the set of integers with elements. Let's call this element small c, such that this is, let's say, ki. Okay, let's use another. Okay, let's use ai sigma n comma I, and we will explain what this means. Here, your ai belongs to the set of integers, and this sigma ni means that it's the ith n simplex. Okay, so what does that mean in particular? So you know that a point is a zero simplex, right? And let's say I have a space like this. The space has nothing to do with it, and inside the space I have like 1, 2, 3, 4 zero simplexes, right? So if I want to point out this simplex denoted by 1, I can write it as sigma 0, 1. It means this is a zero simplex, and there is a comma, and there is 1. That means it's the first zeroth simplex. Similarly, if I want to indicate the second zeroth simplex, I can write it as sigma 0, comma 2. And let's say there is a triangle like this. Okay, a triangle is what? A 2 simplex. So, and let's say this is the only 2 simplex that you have. So if I want to indicate that, I can write it as sigma 2, comma 1. This will mean that I'm talking about the triangle, and so on. So you take a look at the set, and then you identify the n simplex, and you just have to identify its location, and you denote it with sigma ni. That's what it means. So these are the type of elements that we have in the chain group, right? And these elements, that means these elements are called, that means it's a single element, right? And these elements are called an n-chain. So the idea of this n-chain group comes from that if you can construct these n-chain objects, these chain objects, and you can easily show that they form a group. So that's where the idea of the group comes in. It's very easy to show that because you have this integers over here, and you can check that all the 4 axioms of that is required to form a group from a set of elements is satisfied when you have elements like this. We won't go into details for that, but this is what will interest us later on, a little bit later. And we want to introduce another tool that is pretty interesting, and it's called the boundary operator. So now we notice that we gave the simplexes a group structure, which is just an additive group, which is just an additive group. And this is not very interesting. So what we'll do is that we will develop some more machinery or tools to find some interesting results. And with that in mind, we would now like to introduce the boundary operator. So